What are neural signal artifacts, and do they affect data? Imagine trying to listen to a clear radio station, but there's static and noise interfering with the signal. That's similar to what happens in brain recordings when unwanted electrical signals, called neural signal artifacts, show up. These artifacts are signals that don't come from brain activity but can appear in recordings like electroencephalography or electrocardiography. They can make it tricky to understand what the brain is really doing. Neural signal artifacts fall into two main groups. The first is physiological artifacts, which come from the body's own processes. For example, when you move your eyes or blink, tiny electrical signals are generated that can show up in recordings. Muscle movements, like clenching your jaw or tensing your neck, also produce electrical signals that can overlap with brain signals. Heartbeats can create rhythmic signals that sometimes interfere with neural data too. The second group is technical artifacts, which are caused by the equipment or environment. Electrical interference from power lines or even slight electrode movements can generate signals that contaminate recordings. When electrical stimulation is used during experiments, it can produce large artifacts that drown out the real neural signals. These artifacts can seriously affect the quality of data. They can hide or distort the true brain activity, making it harder to interpret what's happening in the brain. This can lead to mistakes or missed information, especially when trying to analyze complex neural patterns. That's why removing or reducing artifacts is so important in neurotechnology. Scientists use different methods to handle artifacts. One way is to prevent them during recording by carefully placing electrodes and shielding equipment from interference. Signal processing techniques like filtering can help remove frequencies associated with artifacts. More advanced methods include source decomposition techniques like independent component analysis, which separates neural signals from artifacts based on their statistical properties. Machine learning approaches, such as deep learning models, can also learn to identify and remove artifacts while keeping the real signals intact. Removing artifacts improves the accuracy of neural recordings. This helps researchers better understand brain functions, develop more effective brain-computer interfaces, and improve clinical tools like neuroprosthetics and neurostimulation devices. In essence, addressing neural signal artifacts is a key step in making neural data more reliable and useful. So, neural signal artifacts are unwanted electrical signals that can interfere with brain recordings. They do affect data by reducing clarity and making analysis more difficult. That's why scientists work hard to identify and remove these artifacts, ensuring the data truly reflects brain activity.